Our 10.7 special segments in a circle. The objective, Buckingham students will find the measure of segments that intersect in the interior and exterior of a circle. Now, this first theorem here, it's talking about chords going through any part of a circle. P is not in the center. It can be, but this does not have to be in the center. It's just any two chords that intersect in a circle. And it says if two chords intersect in a circle, then the product of the measure of the segments, so this is a segment and this is a segment, of each of these chords are equal. So here's another segment and here's another segment are equal. So if I was to take this distance times this distance, it should equal this distance times this distance. So we have that little formula here, AP times PD equals BP times PC. But let's put it into some practice on the next problem, and you'll see a little bit better what that looks like. Okay, so right away here it says, if AP equals X, PC equals 4, PD equals 6, BP equals 3, find X. Okay, so we have the exact same picture as before, but now they're giving us some numbers. So what I'm going to do first, before I do anything else, is I'm going to write out the formula. Well, my first segment is AP, so I'm going to say AP times the other part of that segment is PD. So times PD equals, now the other chord here is CP. So CP times the other part of my chord here, PB. Alright, now let's just plug everything in according to the information they gave me. They said that AP is X, they said that PD is 6, they said that BP is 3, so that's this thing, and CP is 4. Okay, well that means that I have 6 times X equals 4 times 3, which is 12. I divide by 6, divide by 6, and I got X equals 2. Actually, pretty simple. So I want you guys to try practice one on your own. You may pause the video if you like, and I'll put the answer up shortly. Okay, since we're using the same graphic, I used just the same thing, AP times PD equals CP times PB, and I plugged in all the values they gave me, and I said that gave me 3y equals 18, and then I came over here and I divided both sides by 3, and I got y equals 6. And there we go. So that's how you do a problem like that one. I'm going to explain this problem, but what I want you guys to do is maybe just, again, pause the video, look at it, and see if there's any way that you could see how it is really just like the problem we just did. Because it really is, but it's kind of hard to see. So maybe pause the video and give yourself a chance to just think about it first. It'll really help you out. And then I'll explain it. Okay, so the trick to this is, this is just part of a circle. It's not a semicircle, so it's not a half circle, but it is part of a circle still. They say that. So let's draw in the rest of the circle. In fact, I'm going to use yellow since I kind of do it in yellow here already. I know my drawing's not that great. Okay, so we got a faint idea of a circle. Mine kind of looks like a weird egg or something, but still it's a circle. And now if we look at it, we see, hey, look, this is a chord of a circle, and this is part of a chord of a circle, and the other chord would be right here. So let's draw it in. And now we could kind of assume a couple things. Well, we know that this is probably halfway, and this is halfway. So we know if that whole thing is 48, this would be 24, and this would be 24. And we have no idea how big this is or how big just this segment is, so that's going to be my X. And so now I'm going to set this up as one segment times the other segment is equal to one segment times the other segment. So here we go. 24 times 24 is going to equal 12 times X. That's the trick to setting this up. This is really just chords and parts of chords inside a circle. Even though it doesn't look like it, we can always just draw the circle and fill in the information. So 24 times 24, you plug that in your calculator, you're going to get 576, equals 12x, and then you're just going to divide both sides by 12. And you're going to get that x equals 48. Now that, you're not done, okay? We know what x is, but that's not what they're asking for. It says, what is the radius? Well, all we did is find out this distance. But now we should be able to figure out what the diameter is, because it's going to be 12 plus 48, so it should be 60. And if the diameter is 60, that means the radius is half of that, so the radius is 30. There we go. And that's how you solve a problem like that. Let's go on to the next theorem. Theorem 10.16 says, I'm going to have to zoom in here because there's not enough space. It says, if two secant segments are drawn to a circle from an exterior point, so we see from an exterior point going through the circle, then the product of the measures of one secant segment, so the whole segment, and its external secant segment, so the outside part, is equal to the product of the measures of the other secant segment and its external secant segment. So we take the whole thing times the outside part, set it equal to the other whole thing times the outside part. That's all there is to it. So let's take a look at this problem. They give us some information here. I think that you guys can probably try this one. So I'm going to give you guys a chance to try it at home. Look at the formula here and see if you could correspond the parts from this picture to this picture. If you get totally stuck, no worries. I'll explain it in just a little bit. But go ahead and give it a try first. Okay. Hopefully you saw that we need to do the whole thing times the outside part, set it equal to the whole thing times the outside part. So let's do that. We don't have a value though for this outside part, so that's what's going to just be my x. Okay, so let's think about this. Let's first write this out geometrically, right? What's the whole thing? Well, the whole thing is of this top line is P to R. So I'm going to write P and R times the outside part, which is just QR. And I'm going to set that equal to the whole thing on this secant segment, which is RT, times the outside part, which is RS. All right. And now let's just fill in the information. PR, we have a 12 and a 2, so PR must be 14. And we have QR, which they tell us is 2, equals RT. Now, we don't really know what RT is because it's the whole distance, but we can write it as 3 plus X. So let's do that. And RS, which is just X. All right, so we can do a little algebra here. 14 times 2 is 28. And if I distribute that x through, I get 3x plus x squared. All right, so this is turning out to be a quadratic equation. So I told you guys always set these things equal to 0. And so we're going to do that. And I get 0 equals, sorry about a little glitch there, 0 equals x squared plus 3x minus 28 is what you should get when you set it equal to 0. All right. I'm going to zoom in so I have a lot more room to work here, because now we have a quadratic equation and with a really messy x. But we need to be able to factor this guy. So zoom down. Let's make my little x factor that I told you guys about. We put the c term up top, that's negative 28. We put the b term on bottom, that's 3. And now we need something that multiplies up to negative 28 but adds up to 3. Think about it for a second. I already got it. It is 4 and 7. Now wait a second though. 4 times 7 equals positive 28, and 4 plus 7 doesn't equal 3. However, negative 4 plus 7 equals 3, and negative 4 times 7 equals 28. So we can rewrite this expression as 0 equals x minus 4 times x plus 7. And that means the two solutions for 0, the two things that I can plug in here are positive 4 and negative 7. So we could say x equals 4 and negative 7. All right. A lot of work there, a lot of algebra, but nothing you guys haven't done before. And let's take a look. What do they really want us to do? They want us to find RS, or what we called x. And so we did. Now here's the thing. Could this distance be negative? And the answer should be an obvious no, because we can never have a distance that is negative. So we can automatically cancel out that negative 7, and the answer 4 is our only correct answer. Okay, let's move on to our last theorem and then our last problem. What I want to point out, though, is that this theorem that we just did is really not that different from this one. Here we're dealing with a tangent and a secant, and here we're dealing with two secants. But if you think of it like this is still, you could still treat it like a secant. It's just that, remember we were doing the whole thing plus the outside. Here, this is the whole thing, and it's the outside. So we're going to just use the same number twice here, and that's okay. So think of it like that, but I'll read through the theorem with you anyway. It says, if a tangent, segment, and a secant segment are drawn to a circle from an exterior point, then the square of the measure of the tangent segment is equal to the product of the measures of the secant segment and its external secant segment. Okay, what that means is, look, here's my tangent, and here's my secant. Again, the square of the measure of the tangent segment, so uv times uv, is going to equal uy times ux, and that's what we have here. So it's the outside times the whole thing. Well, that just happens to be the same amount when the line is tangent, so it's rather simple. Okay, well, let's take a look at this problem. Now, just so you guys know, we're going to have to remember some old stuff from algebra, and I'll go over some review on that in a little bit. But first, let's just look at how we set up the problem, since that's the theorem we just learned. All right, well, we have my tangent line 4, and it says that I'm going to have to take the square of that tangent line. So I'm going to do, well, actually, yeah, I'll label it out geometrically. So that means I'm going to have to do AB times AB is equal to the whole thing, which is BD, times the outside part, so BC. Okay, so let's plug that in. We know that AB is 4, so we can plug that in. We know that BD is a little tricky because it's two things. It's x plus 2 here and x here. So we could write it as x plus 2 plus x. And then BC is just x. All right, we got a lot of x's there, so let's make sure we use our order operations and simplify it correctly. First things first, 4 times 4 is 16. And inside these parentheses, I have an x and an x. So I can combine those like terms and give myself 2x plus 2. And the whole thing is times x. So I'm going to distribute that x through, and I get 16 equals 2x squared plus 2x. And again, we have a quadratic equation. So we are going to need to set it equal to 0. So I'm going to subtract 16 and subtract 16. And so I get 0 equals 2x squared plus 2x minus 16. All right, well, first thing I see here is that we have a 2 and a 2 and a 16, and those are all even numbers. So I'm going to go ahead and divide everything by 2, just to see if I can reduce this whole equation down. And I get 0 equals x squared plus x minus 8. All right, now before I told you to factor these. You make your x factor, you put your c term up here, put your b term up here. But we have a problem. There are no numbers that multiply up to -8 and add up to 1. Try it. The only factors of -8 are 8, 1, 2, and 4. So 8 and 1 certainly doesn't add up to 1. And 2 and 4 will never add up to 1 because they're 2 apart. So you could get a 2 out of there, you get a 6 out of there, but it won't. Those won't work. So this is a problem where it is not factorable. And as of yet, we have not done problems in geometry where there is something that is not factorable. But you did do this in algebra. And so I'm going to do a little review. Let's push this off to the side. We'll get back to it. There was a formula that your teacher told you was really important. They probably made you memorize it. They may have even made you sing songs about it. And it had to do with what happens when you get an expression that looks something like 0 equals ax squared plus bx plus c. And I don't know how different people have told you, but I like a story. So here's my story. There once was a pessimistic bee who wasn't sure whether or not to go to this radical party where the bees were square dancing and playing poker, but the deck was missing 4 aces, and the party was all over at 2 a.m. And that's just my little tricky way of memorizing it. But there's lots of other ways out there if you want something better. But this, ladies and gentlemen, this is the quadratic equation. This is how you solve a quadratic equation that doesn't have, that's not factorable. So we're going to use this equation on this problem. But I wanted to just kind of give you a recap of it, and hopefully you guys have some memory of that. Okay, so let me shrink that down, put it up here in the corner, and bring our notes back. Okay, remember we left off with this. 0 equals x squared plus x minus 8. It wasn't factorable, but we can use this equation to solve it. So we would write x equals negative b. Well, my b in this situation is the second term right here, and it's just 1, because there's no real 1 there. So we're going to write negative 1 plus or minus the square root of b squared, which is just 1 squared, minus 4 times a. And look, a is just 1. There's nothing in front of it, so it's just 1. Times c. C is this last term all by itself, so it's negative 8. All over 2 times a, which is also 1. And now we just have to simplify this thing down. It's really not as hard as it looks. I get x equals negative 1 plus or minus 1 squared is just 1. And then this whole thing is really just negative 4 times negative 8, which is positive 32. And then that thing is all over 2. And we can keep going a little bit. Let me shrink this down a tad bit more. Let's see. 1 plus 32 here is 33. So we could say equals negative 1 plus or minus the square root of 33 all over 2. Now, algebraically, this is really as simple as we can get it. And I know it looks messy, and that's because it is. It's not an easy number. But that is an answer. That is a fine answer. But if you needed to, you could plug that into your calculator, and you should get back one of the possible solutions you should get back is 2.37. So that's adequate. 2.37 is the number that we're looking for x. So I know that was kind of a lot, but there's your solution. X equals, or x is approximately 2.37. I had to do a little bit of throwback there, but you guys are capable of it. So talk to you guys next time.